Okay, welcome, April 2nd. In today's edition of Kitchen Table Chemistry, I'm going to try and teach you a little bit about Boyle's Law. Boyle's Law is the relationship between the pressure and the volume of a gas, and it was what yesterday's assignment was based on. Boyle's Law looks like this. Move myself up here, and here we are. The relationship between the pressure and the volume are inverse. So as pressure goes up, volume goes down. The P1V1 equals P2V2 is the relationship as is written mathematically. And please go and put that on the back of your periodic table so you're never at a loss for it or where it is. Notice the temperature is not addressed in this law, and that temperature has to be held constant. Boyle's law is kind of interesting, and as you might surmise by Henry the vacuum cleaner down there, Boyle's law is how vacuums work. Now, examples of Boyle's law would look like this. Well, first of all, breathing. If you watch the video that I embedded there, that YouTube clip, you can see that's how your lungs actually work. And if you've never thought about how you breathe, there you go. You have to lower the muscle, the diaphragm, at the bottom of your thoracic cavity. That increases the volume. In other words, V goes up, which means the pressure in your lungs go down, and then air gets drawn in. And that's how you breathe. It's kind of an interesting way to think about it, and that is what works. And that breathing is a negative pressure situation where you create negative pressure inside to draw in fresh air. Vacuum cleaners, as I said before, are operated under Boyle's law. What the vacuum does is create a low pressure system in front of the nozzle or the hose, and that's how things get drawn into the vacuum. And that by creating low pressure and that by trying to decrease the volume, that vacuum fan that runs in there. And lastly, scuba diving. Don't want to get into it too much, but scuba diving, you have to keep the lung pressure constant. Uh, it's something else. I will link a video here on it, but I don't want to explore it too much. If you want to know one thing in life that I'm never going to do, is to go scuba diving. And it's because of Boyle's law. All right, what does this mean? Well, when can we use Boyle's law? We can use it when temperature is held constant. Temperature must be constant because temperature is the energy of the particles. We can't be adding to them because that would change the situation. And the amount of gas. The particles or moles must be held constant as well. And if these things are both constant, we can use Boyle's law. Here's a little bit of a practice problem. What is the new volume of a gas if the original volume is 3.5 liters at 100 kilopascals and the pressure is increased to 150 kilopascals? Notice that both pressure units are the same, kilopascals, so we don't have to modify anything. And we're going to get an answer in liters because our given was in liters. So V1 to start with, 3.5 liters. P1, initial pressure, 100 kilopascals. V2, which is the X we're trying to find, and P2, 150 kilopascals. Now, you there at home, what is going to happen to the new volume? Because we're going to increase the pressure, pressure will go up, the volume will go down. Mm-hmm. So here's how it's solved. 3.5 liters times 100 kilopascals on one side, that's our V1 or P1, is equal to V2, the new volume, times 150 kilopascals on the other side. We simply collect and then we will solve. Kilopascals will cancel out and it'll leave the only unit left, which will be liters, and that will create a V2 of 2.3 liters. Makes sense. As the pressure goes up, the volume went down, and that is the ratio. All right, I'm going to add some practice problems here at the bottom of the assignment. Give them a try, and as before, take a picture of them and send them to me, or send somehow, and I just link them, and I'll take a look at how you're doing. It does help me figure out what you're learning here as we go through this process together. As always, as you can see, I've got a YouTube channel now. Please tell me how I can be more efficient, more effective, more interesting than what I'm doing. I'm always up to improve, and this is a new process for me as it is for you. I hope this video finds you well at home and comfortable. If you are an an essential employee and you're still out there at work, please be careful, please be safe, and I dearly hope that people are treating you well in whatever it is that you have to be out there doing. All right, this is signing off for Thursday, April 2nd. Take care. Again, contact me if you need anything, and I look forward to speaking to you again tomorrow. Bye bye.